provided by Thomas Allgaier and Frennis, based on the most relevant LinkedIn posts about charging and battery technology in calendar weeks 30 and 31. Frennis is a B2B market research company that supports automotive suppliers with building feature-by-feature competitive intelligence that shows exactly how their product stacks up against the competition. You can find more info in the description.
So imagine pulling up to a taxpayer-funded EV charger only to realize there's like a coin flip chance that it's just completely dead.
Yeah, the worst.
Right. Today, for this deep dive, our mission is to unpack the most critical charging and battery tech trends for you. Because if you're a next-gen mobility professional, you are dealing with this shift every single day.
You really are. I mean, the industry is just undergoing this massive shift right now. We're finally moving away from that raw kilowatt chasing where it's all about who had the biggest number on a spec sheet and moving towards solving the gritty operational realities of access and reliability.
Exactly. The conversation is totally pivoting from pure speed to just basic access. Like, look at the example Alexander Mirapolsky shared recently.
Oh, right. The road trip.
Yeah, he took a European summer road trip in a Volkswagen ID, Buzz, and the sheer number of recurring failures he ran into was wild.
It sounded like a nightmare, honestly.
It really was. I mean, he was dealing with apps that showed chargers were available, but when he actually pulled up, they were completely full.
Which is just so frustrating.
Totally. And then he had charging sessions that would just abruptly stop at 54%. Just bam, stopped. Plus a complete lack of remote start compatibility and all these roaming failures across Sweden and Norway.
Wow. And, it's not just Europe. I saw a really similar parallel example from Rahul Piyadav. He actually drove an EV 2,800 kilometers from Delhi to Mumbai and back.
That is a serious distance.
Yeah, it's massive.
Yeah.
And his big takeaway was that the anxiety for drivers isn't actually about vehicle range anymore. Like, it's about the uncertainty of the infrastructure.
So just not knowing if a station is going to work?
Exactly. He said finding chargers wasn't the issue. They're out there. It's finding ones that actually worked. I mean, he was running into frozen displays, handshake errors where the car and charger just won't talk to each other.
Right, the classic communication drop.
Yeah. And get this, chargers that were listed as live on his app, but literally had weeds growing through the bottom of them.
Okay, weeds. That's when you know it's bad.
Right.
But I mean, that anecdotal stuff totally validates the hard data we're seeing. Prians M shared some numbers recently, and India actually just crossed 1 gigawatt of public charging load.
Which is a huge milestone.
It is. But they did an audit across 84 different operators, and it turns out 34.42% of CCS2 and Type 2 chargers are just offline.
Wow. Over a third.
Yeah. And for public sector operators, that number jumps to 51%. Over half are dead.
That's just wild. And, it makes me think, and I'd love to offer a bit of pushback for you to think about here. Are we, as an industry, just totally obsessed with the wrong metric?
Like focusing too much on speed.
Yeah, exactly. We constantly push for these flashy 600 kilowatt mega chargers. But Alexander Close made this really great point. He noted that an 80 kilowatt hour battery needs about 13 minutes to charge to 80% at 250 kilowatts.
Okay.
But if you go up to 600 kilowatts, it drops to 6 minutes. And I mean, most users won't drive out of their way just to save 7 minutes.
Yeah, that's a really fair point.
It's kind of like, well, it's like buying a $10,000 commercial espresso machine for your home kitchen, Like, sure, it's fast, but a reliable standard coffee maker is actually what you need to just get your caffeine and get to work on time.
That's a perfect analogy. Dense, reliable 250 to 350 kilowatt networks are just way more practical.
Definitely.
And speaking of practical, CJ Johnson shared a really interesting strategic point on this. Walmart is quietly dominating the charging space right now.
Really? Walmart?
Yeah. While all these dedicated charging operators are like scrambling to find locations and overpaying for them, Walmart added over 8% of all new fast charging ports in the U.S. last quarter.
That is a massive chunk of the market.
It is. And the thing is, they aren't trying to be an energy company. They just realize that EV charging has essentially become a commercial real estate business.
And they already own the best corners.
Exactly. They have the massive grid hookups. They have the parking lots. It's brilliant.
It really is. Though, just to round out this whole infrastructure theme, Kate Kudoli shared a quick data hit that puts public charging in perspective. Despite all these public network struggles we just talked about, home charging is still absolutely king.
Oh, for sure.
Yeah, it accounts for 96% of the roughly 366,000 new UK charger installations modeled for 2025.
Wow. 96%.
Yeah, massive.
Well, since we just talked about the, diminishing returns of ultra-fast charging for consumers, maybe we should pivot and look at what high-speed charging actually does to the physics of the battery.
Let's do it.
And hey, real quick, if you want to catch our future deep dives where we track all these engineering shifts, make sure you hit subscribe so you don't miss them.
Good call. So on the battery health side, Merlin Frank brought in some really interesting data, citing Geotab's 2026 EV battery health analysis.
What did it show?
Well, it shows that mostly AC or low-power charging results in about 1.5% annual degradation.
Which is totally expected, right? Normal aging.
Yeah, totally normal. But frequent high-powered DC fast charging can push that degradation up to 3.0% per year.
Right, and Dr. Manjeet Singh Gruel actually explained the science behind why that happens. The main culprit is lithium plating.
Lithium plating, how does that work?
So at high C rates, the lithium ions are moving so fast that they can't intercalate or embed into the graphite anode fast enough.
Okay.
So instead of embedding, they just plate as metallic lithium right on the surface of the anode. And that causes irreversible capacity loss, thermal stress, and even electrode cracking.
That sounds pretty severe. But, I do want to push back on the doom and gloom a little bit with some real-world data from Dr. Isabel Sheldon.
Okay, what does she see?
She actually checked the telemetry on her own BMW i4 using the Car Data portal. And after 62,000 miles of real-world driving, her battery still had 94% of its original capacity remaining.
Wow, 94% after 62K miles.
Yeah. And if you extrapolate that, the battery won't even hit the 70% warranty threshold until around 310,000 miles.
That's practically the lifetime of the car.
Exactly. It's like high-power fast charging is like sprinting. I mean, you wouldn't sprint everywhere you go, right? Your body would just give out.
Right, totally.
But doing it occasionally when you're on a road trip, it's not going to permanently ruin your body. The battery will outlast the car if the thermal management system does its job.
That makes total sense. But of course, eventually these batteries do age out, which brings up the second life economy. And Maciej Mikulich had a really strong warning for professionals buying into this space.
Oh, what was the warning?
He warned against buying used EV battery modules based on just a single average state of health metric.
Because an average can be misleading.
Exactly. An 80% average could look great, but it might hide a batch of modules that have severe cell imbalances or mechanical damage. So buyers really need individually tested results to actually judge their integration costs.
That is super important to keep in mind. Though speaking of the Second Life supply chain, I saw a really surprising insight from Leanne de Beaucaire. She visited Moment Energy's massive Second Life EV battery repurposing site in Vancouver.
Okay.
And the biggest feedstock they are processing right now isn't actually retired EV batteries.
Wait, really? What is it?
It's surplus new batteries resulting from overproduction.
Oh, wow. So brand new packs that just never made it into a vehicle.
Exactly. Just straight from the factory to the Second Life market.
That is wild. But those Second Life batteries are becoming incredibly capable as standalone products. Jonathan Carrier highlighted this company, Ally. Their MX300 mobile battery is a 300 kilowatt-hour system.
That's a huge battery.
Yeah, and it can now plug directly into a public CCS2 DC rapid charger. It just hooks up and recharges from 20% to 80% in just over an hour.
Oh, that's brilliant.
Right. It completely removes the need for dirty diesel generators on construction sites.
That is such a good use case. And, connecting that massive Ally mobile battery to the broader scaling of heavy-duty energy needs. I mean, the biggest infrastructure challenges right now are really shifting to commercial fleets and bidirectional grid integration.
Oh, without a doubt. Sebastian Lucchi brought this up, noting that ECOG's 2030 market model actually projects that commercial fleet charging demand will overtake passenger cars globally by the end of the decade.
Really? By 2030?
Yeah, and that massive amount of energy will primarily be delivered through depot charging behind the fence.
Which makes sense, because the hardware for this is finally arriving. Jort-Jan van Gestel reports that MAN is actually running series production right now of MCS-ready trucks.
MCS, the megawatt charging system.
Yeah, exactly. And these trucks are capable of charging at up to 750 kilowatts.
That is a staggering amount of power to push into a vehicle.
It is. And Nicole Shelton added that Tesla just opened its first public megacharger site in the U.S., which can deliver up to 1.2 megawatts across 6 different stalls.
1.2 megawatts. That's just crazy. And there's a massive influx of funding helping to accelerate all this. Javier Martin del Campo highlighted the EPA's Clean Ports program.
Oh, yeah. The grants?
Right. They just released a $75 million zero-emission truck RFP. It's offering up to $300,000 per battery electric Class 8 truck, specifically for the San Pedro Bay ports.
That kind of funding is going to move the needle fast. But, there's a competing parallel path for these heavy trucks that we have to mention. Michael Barnard shared some data on battery swapping.
Oh, swapping, right?
Yeah, CATL's Kiji program in China has already built 305 heavy truck swap stations, and they're aiming for 900 by 2026. A truck can pull in and in about 6 minutes be back on the highway with a full pack.
6 minutes entirely neutralizes the whole charging downtime argument.
It really does.
But I've got a provocative question for you on that. Swapping is efficient, sure. But if it takes hold in Europe, do European OEMs end up just surrendering the core operating rules of their freight systems to a single battery provider like CATL?
Oof. If CATL dictates the chassis design to fit their swap mechanism, the legacy OEM is basically just building a metal box around someone else's tech ecosystem.
Exactly. It's a massive shift in power.
It is. But bringing it back to the grid, there is a massive standard update from Mark Moulton that totally changes the game for vehicle-to-grid, or V2G.
Okay, what's the update?
It's the recent ISO 15118-20 Amendment 1.
And why is that one such a big deal?
Because it allows an AC-connected EV to finally behave as a certified grid code compliant generator.
Oh, wow. So it's not just a small pilot project thing anymore.
Right. It moves V2G into scalable commercial reality because the car can autonomously respond to grid frequency changes in milliseconds.
That is incredible. And, synthesizing all these trends, Walmart mastering charging real estate, CATL standardizing truck chassis, it leaves us with a really provocative final thought for you to mull over.
What's that?
The future winners in e-mobility might not be the traditional car makers at all. What happens to legacy OEMs when the real profit shifts entirely to the companies controlling the physical parking lots and the bidirectional grid software?
That is a fascinating question. We'll have to see how it plays out. If you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on commercial fleet insights, autonomous and mobility markets, and software-defined and AI-defined vehicles.
Thanks so much for diving into all this with us. Keep pushing the industry forward. Make sure you're subscribed, and we'll catch you on the next deep dive.